Welcome back, everybody. I am so excited to welcome Marc from the Ethereum Foundation Python team, also known as the Snake Charmers.
Hey, everyone. I'm excited to be here. Thanks, PyChain, for having me. I'm glad this conference exists. In general, I'd love to see more shared learnings from Python devs in our industry. So let me get the screen share going. Oh, no, wrong one. Let's try that again. Okay, I think we're good now. Yeah, so shout out to Melissa and the conference organizers, Miko, Georgie, and the team. Today, I'm going to give you a quick introduction into Web3.Py, and then we'll highlight some of the latest updates from this year, talk about our roadmap and how you can influence it. So I know this audience is a little bit more chain agnostic, so there's a little bit of, we'll call it Ethereum-centric content in here, but also some goodies in here for everyone. So let's start with why. My why for giving this talk is that I believe the successful adoption of decentralized technologies depends on you, the builders and the founders out there, being able to solve local problems. So my goal for this talk is just to raise awareness for some tools that are already in your tool belt that you might not yet be familiar with, and to invite you into shaping the next iteration of these tools. For context, let's go forward. For context, a lot of what we'll talk about will be available on the EF Python team blog, snakecharmers.ethereum.org. So I'll remind you of that URL again at the end of the talk. But for my part, I joined the Ethereum Foundation about 5 years ago, starting on a couple of JavaScript teams, and a couple of years ago, hung up the JS hat to join the Python team, also known as the Snake Charmers. So our team has recently grown to 5, and we are responsible for maintaining about 10 Python libraries with the help of our awesome community of open source contributors. We appreciate all those issues, pull requests, rubber ducking, and helping out with answers in the forums and all these kinds of good things. Today, we are interested in Web3.Py in particular, so let's start there. Let's start again with the why question. So why does Web3.Py need to exist? The short answer is because Ethereum execution layer clients communicate via JSON RPC. So if you want to communicate with your Nethermind, your Geth, your Aragon node, et cetera, if you want to do that via command line, you will be putting together this curl request on the left here, where you're sending out this stringified JSON object and getting this data blob in return, which is then up to you to decode and make sense of. Web3.Py gives you a Python alternative to that. That's quite a bit more human friendly. So you can make the request for whatever it is you're interested in fetching and hopefully get that result in the desired format. For those of you interested in a deep dive about how this works under the hood, check out the blog. What might you know Web3.Py for already? First, that you'll need to configure a provider to talk to whatever node it is you're interested in. This could be a mainnet Ethereum, but could also be an EVM compatible alternative layer 1, or some side chains or layer 2 rollups, etc. Once connected, you can do a set of basic things like look up account balances, convert currency denominations, send Ether from one account to another, deploy smart contracts, interact with deployed contracts, read block or transaction data, watch for events as they occur on chain, and so on. This is sort of the basic set of functionality that you can do with Web3.Py. That was covered intentionally quickly. If these concepts are unfamiliar to you, I recommend checking out our introductory blog posts and some of our documentation to get started. And welcome to this weird and wonderful world. In the meantime, let's chat about what's new this year for Web3.Py. And for us, a lot of our energy has gone into some concurrency features, namely the async HTTP provider. This is available today in beta and recent version 5 releases. It's a little bit verbose to use today, but that'll get cleaned up before version 6 is fully out of beta. And the takeaway here is that you can use all the basic functionality that you're familiar with in async IO patterns now today. So for the sake of example, we're just fetching the first 50 blocks in the chain using this async IO as completed method and logging them out as soon as they return from that round trip to the remote node provider and back. So you see them logged out in a fairly random order there at the bottom. So maybe doesn't need saying, but if you're using async patterns, then make sure to customize them for whatever is relevant to your use case. The flip side of this takeaway here is that if you spend most of your time waiting on a return trip to and from a remote node, then you can see some pretty serious performance gains by switching over to an asynchronous pattern. Moving on to ENS, the ENS module within Web3.Py has similarly gained an async compatible upgrade. So similar example here, as completed, we're fetching Shaq, Vitalik, and Paris Hilton's addresses 30 times in rapid succession, and we are expecting to see some pretty serious gains in performance in doing so. So similar outcome there. Finally, multi-threading support is got some love this year. The library is intended to be thread safe. So if you find any bugs there or can disprove that theory, we'd appreciate you opening an issue. Otherwise, not going to spend a lot of time digging into the threading feature here, but for more context, check out this recently published blog post. And as a rule of thumb, our team recommends reaching for the async provider if you can. If you can't, because some feature you rely on is not available yet, or because you rely on some dependency that's not async IO compatible, then reach for threads. Next feature set here. This is a fun one introduced this year. A feature called CCIP read, which is a pattern for retrieving off-chain data. So this EIP was introduced by Nick Johnson of the ENS team, and their use case they were interested in was having or registering ENS subdomains on, for example, a layer 2. So this is a interoperability motivated proposal. What this EIP fundamentally introduces is a new pattern for Ethereum smart contracts to indicate that an off-chain data lookup is required. So how it does this is just by stipulating a special case error message where you can include the URL by which some off-chain data will be fetched from, and then a callback function that the data which returns from that off-chain source should be funneled back into so that it can be verified as authentic. So we're going to step through a quick use case here. This diagram is included in that EIP. In our case, our client is your Web3.Py script or dApp. The contract we're interacting with is a ENS resolver contract, and we're communicating with an optimism gateway to get our off-chain data. So this back and forth goes something like this. Web3.Py will ask the ENS resolver contract, where can I get the address for this subdomain? The resolver contract recognizes that it is not registered on layer 1 Ethereum, but it can be found over here via this optimism gateway. And so it sends this custom error message back to Web3.Py. And under the hood, without the user having to know anything about it, Web3.Py will handle this custom error and send either a GET or a POST request over to that optimism gateway and get that response back. So continuing under the hood, the user doesn't need to know what's going on still. We pass the results back to the callback function originally specified, and the ENS resolver contract will then read the signature that accompanies that result data. And if it verifies it as authentic, then we'll pass that value back to the user. So this is the whole flow. There's a fair bit going on here, but from a user's standpoint, or from you, the developer's standpoint, potentially, this is very straightforward, right? So you're looking for an address from a name, and you will just get an answer back so long as you trust that ENS resolver contract. Again, this use case is not limited just to ENS, so we are fetching some data off chain, and this is one example use case. For ENS's sake, they need to make an update to how their resolvers work to handle this new case. So in this ENS IP10, you'll find some sample code for their resolver if you want to compare notes about how they do this signature verification and those middle steps there. Just a fun adoption fact here, the Lens protocol folks are leveraging the same pattern to serve their social graph data. So if you're looking for another use case to poke around in, that one might be a fun one. And if for whatever reason this functionality introduces some security trade-offs that you're not comfortable with, you can disable them altogether at the provider level or at the individual call level. So important to note is that this functionality is only enabled for calls and not transactions, but still you might find need to turn that off in specific cases. For more context here, check out the blog. Next up, if you are looking to do something outside of the normal scope of Web3.Py, you've got a few options, and these might also be interesting to those multi-chain folks. The first is middleware. This is just a way to inject some behavior either directly before any given request is made or just after a request comes back. So you might use this to do some request manipulation in some form or to do some custom logging behavior. Once you've written your middleware, you can inject that into what we call our middleware onion. Custom methods is another option you've got. So if you're using effectively all the clients these days have some set of non-standard JSON RPC commands that they offer. And if you'd like, you can just register those directly on the ETH module or whatever makes sense there, utilizing our data formatters as you see fit. Third, you've got external modules. This is effectively plugin support. So this is very flexible. We just require that these be classes. And if you need to make use of the parent Web3 object, that's available in the init method of any given class here. You can nest these. It's a flexible, wide open canvas for you to introduce, whether it be entire like layer 2 APIs or some other batch of functionality. If you're using these, we'd like to hear about it, either to help you get some exposure to that library or to better understand how users are using the tools. So you could provide these publicly for use or maybe just create these sort of plugins internally for your team. Next up, we've got custom providers. This enables you to like fundamentally alter the way that every request is made. Maybe if this is a good use case for like a custom test harness, those types of things. Otherwise might not be that broadly applicable. So finally, monkey patching, do what you got to do. For more context about when you might reach for each of these, check out the blog. Now up, we've got the merge. So this is more Ethereum centric. The merge happened a couple months ago. What do you have to care about as an Ethereum specific developer? First, we've got a couple testnet deprecations. Goerli and Sepolia are still good options, so long as you can find some faucet funds. Block times have updated in a meaningful way in some use cases. So it used to be that a new block was added to the Ethereum blockchain every 13 seconds with high variability. Now it's every 12 seconds even with much less variability. And that very quickly happens by every 12 seconds, a new slot becomes available and a randomly chosen validator has the opportunity to propose a block to fill that slot. If a validator is offline, for example, you might not have a block every 12 seconds, so it might pick up again after the 24 seconds. Block identifiers, you might be familiar with latest, pending, and so on. We've got a couple new ones, safe and finalized, to check out based on your use case. And then the Beacon API continues to exist, but maybe it is more interesting to you now post-merge. And there is a asynchronous capable Beacon API that went out in yesterday's release of the latest beta version. Next, we've got about 4 minutes left, so we're going to chat about some upcoming stuff and some basically how we think about our roadmap. So the first thing I would like to encourage you to do is fill out a user survey that we've just created. This is the best way to get your cares, concerns, wish list, etc. onto out in front of us. So please screenshot that. Take that survey when you get a chance. The way we think about planning our roadmap is typically done in, we haven't found value in doing this very explicitly in more than 1 to 2 quarters in advance, just based on how quickly this industry moves. We operate a pretty, we'll call it a negotiable roadmap. So we tend to prioritize feature requests and in particular bug reports that come in from our users above any sort of some categories of like wish list features that we might be maintaining. And if you're curious about what we've prioritized this year, a lot of that was covered in this talk. So for the end of the year, our primary focus is still hacking away at the next major version release of Web3.Py. That's version 6. And beta versions of that have been available for quite some time. We just released another version yesterday. Version 8 is out available. So the async drum is one we will continue to beat. We're going to continue fleshing out the remaining middleware and filter features and so on. And of note, there are quite a few breaking changes in this release, and many of them are very straightforward to resolve. We have finally ripped out the last of the JavaScript syntax, the camel casing that we've inherited from years past. So snake casing all around. There's some other less straightforward ones, but a migration guide is in the works. For the next year, our priorities look similar. Your priorities will continue to be our priorities. Async functionality will continue to be fleshed out. We've got some tooling updates that we would like to make, as well as some benchmarking and optimization that we hope to do. But otherwise, we have a steady diet of keeping up with Ethereum network upgrades in the form of EIPs. And we're continuing to hope to make life as easy as possible for our friends downstream at Ape and Brownie. About to wrap up here. Finally, please do take the survey. That is how we are going to make a number of our decisions for priorities. And if you missed anything we chatted about, again, snakecharmers.ethereum.org is a good place to catch up. That's all I've got for you. Thanks for your time.
Thank you so much, Marc. That was awesome. We enjoy the Snake Charmers team. So yeah, and actually ApeWorks, we do give out some testnet tokens for engagement. So got to get into our Discord. Yeah, so thanks again. And we are live again in the next few minutes for our main stage chat. Bye.
Cool. Thanks, Melissa.